Now remember we talked about that you should know, because you just had your quiz, you should know that sine of any point is y over r, right? But on my unit circle, what is my r always? 1, hence the term unit. It is 1 unit. So that means that the sine of your value that you're talking about is just going to be y, okay? My cosine of any theta is going to be x over r, but again, my r on the unit circle is just 1, so it's an x. And then my tangent of anything is going to be y over x. That's true just all the time because your r is not involved, okay? So if I'm asking what is the sine of 0, 0 is my theta. 0 is what I'm putting in. Sine would be what I'm taking out. Like, what is the sine? That's my y value, okay? So if I want the sine of 225 degrees, I'm going to go to 225 degrees and give you my y value, negative square root of 2 over 2, okay? If I say what's the cosine of 5 pi over 6, I'm going to go to 5 pi over 6 and give you the x value, cosine, negative square root of 3 over 2, okay? If I want the tangent of 315 degrees, then I am going to say y, negative square root of 2 over x, square root of 2 over 2, negative 1, okay? So using this unit circle, I can get any of the 6 trig functions because I know my x and y, which is what your quiz was just on, filling out your x, y, and your degrees and radians, okay? So if I ask for sine of an angle, and it's one of your angles on the unit circle, I am asking for the y value at that angle, where it ends on the unit circle, okay? If I ask for cosine, I'm asking for the x value, all right? So if you have this guy in front of you, more importantly, if you have it memorized, then I should be able to call any angle on this unit circle, and you should be able to give me this one of the 6 trig functions for it, okay? So that's all we're doing when we're graphing these. The first thing I want to do is kind of just go through how we would plot these on a graph. So if you have your unit circle filled out, which hopefully... So if I were to go through this, and I am just going to, for this one, look at the sine graph. So, and when I say I'm going to use x and y's, but as input and output values, okay? So I know on your graph, your x is cosine, your y is sine, right? Okay. But when I'm talking about it here, if I were to say that y is going to equal the sine of x, x is just my input value, y is my output value, okay? And so if I start at 0, so let's start at 0, I would say, well, if I know that x is 0, the sine of 0, and we're in radians, equals what? If my input is 0 radians, what is the sine of 0? If I input a radians of 0, my y value there is also 0. Does that make sense? The sine of 0 is 0, okay? So let's go to the next one. Let's look at pi over 2. That's a good one. Pi over 2. If that is my x value, that's my input. I'm inputting pi over 2. What is the sine of pi over 2? Yeah, 1. So my y value at pi over 2 is 1. Does everybody see that? So I'm inputting pi over 2. My output then would be 1. Yes? And then what about pi? If my input is pi, what is my sine value at pi? I'm graphing sine. My sine is 0 again. Everybody see the y value at pi is 0? And so that's going to be 0 at pi. What about 3 pi over 2? What's my sine value at 3 pi over 2? My y value, yeah, is going to be negative 1. And then back at 2 pi, which is the same as 0, right? It's going to be 0 again, right? But you see how that went. Now let's say I go negative. So start at your 0, just here for y'all. negative pi over 2. So let's say we want to input negative pi over 2. What is my y value or my sine value at negative pi over 2? Negative 1, right? So that's there. What's my sine at negative pi?
Negative 1.
Just 0. All right. When we're graphing these, if I say I'm only looking at sine value for this graph. So my horizontal axis represents the angle I'm talking about. The vertical axis represents the sine value, okay? So my vertical axis is going to be my sine value, all right? My horizontal axis is actually theta itself, the angle I'm talking about, all right? So if I say, what is the sine of 0? What I'm saying is on the unit circle, if you go to 0, what is your y value? 0. So my input is 0. And so my point on the coordinate plane is 0, 0 here. Okay? Here, I said, what is the sine value of pi over 2? Pi over 2 is my horizontal movement. 1 is my vertical movement. So I'm going to go to pi over 2, 1. That is my coordinate for this. So instead of using, the only thing that's different here is your horizontal coordinates are written in radians. So you're not quite used to it. So instead of it saying 1, 2, 3, 4, 5, and your coordinate being some pretty 1, 1, your coordinate is pi over 2, 1. That's your coordinate here when you were to graph it. Does that make sense? More sense? Okay. So sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. Sine of 2 pi is 0. If I go this direction, sine of negative is negative 1. Sine of negative pi is 0. Sine of negative 3 pi over 2 is positive 1. And then you'll see that it goes back to your 0 as well. And so if I were to graph just the sine function, my input is my angle, my output is my sine. Okay? And so what does that look like? Well, if I were to connect these dots, it's going to be a wave. So your sine graph is a wave, and you'll see that. Now this makes sense because what's happening on the unit circle? You're just going in circles, right? So the graph of sine is not a circle, all right? Think about a Ferris wheel, all right? Let's see, or actually, when you're going up and down, it's basically the distance from your middle, okay? So let's say the very middle, the axis of the Ferris wheel, all right? If I were to draw what that graph looks like out this way, if you started in the middle, then as you go up, you get away from the middle, right? Then you go back down to the middle, then you go below the middle, then you go back up to the middle, then you go above the middle, then you go down. And so if you were to graph, quote unquote, how you are riding on a Ferris wheel compared to the center of it, it would look like a sine graph, right? You get the exact distance away, you get back to the middle, you get the exact distance away below it, okay? And so that's what happens on a cyclic function like this for something like sine and cosine. They end up being this perfect little wave that happens when you graph them out this way as far as input and output goes, okay? Make sense? All right, so basically cosine does the same exact thing. It looks identical, it's just moved, all right? Because you don't actually start at 0 for cosine. So if we look at the graph, I started at 0, went to my highest value, back down to my middle, down to my lowest, and back up to my highest. Let's talk about the sine graph. Sine graph is divided into 4 pieces, like I just said. You're always going to start... You're going to start at your 0, your midline, okay? Start at your midline. 1/4 of the way through, you will be at your highest. Halfway through, back at your midline. 3/4 of the way through, you will be at your lowest. And you will end at your midline. That is sine graph, okay? That's how it always works. Cosine, same thing, but for cosine. Cosine's the x value. So y equals the cosine of x. My x value meaning I'm talking about the input of my degree, my radians, right? So this is my theta. All right, and my y value represents the cosine value. So my y value is going to be, the output is going to be my cosine, okay? Input is the angle I'm putting into it. Output is the answer of what is the cosine, all right? So if I do this all over again, and I start at 0, what is my cosine value then at 0? 1, right? Because we're talking about the x values. If I go to pi over 2, what is my cosine at pi over 2? 0. Pi, what is my cosine at pi? -1. 3 pi over 2? 0. And 2 pi? 1. If I go back the other direction, so start here and go down, all right? Negative pi over 2, what's my cosine there? 0. Negative pi? Negative 3 pi over 2, you're at the top now, 0. And 2 pi? You're back at 1. And so if I were to connect these guys, you would actually see the same curve, looks identical, but he just starts at a different point, if I could draw it neatly here. All right, and so this is my cosine graph. So whereas for the cosine, I start at my highest, go to 0, down to my lowest, back to 0, and then back up to my highest. Let's look at cosine graph. You start at your highest. Depending on what your amplitude is, it could be 5 if your amplitude is 5. It could be 1/2 if your amplitude is 1/2. But you start at your highest. 1/4 of the way through, you are at your midline. Halfway through, you are at your lowest, based on your amplitude. 3/4, you are back at your midline. And you end at your highest. That is cosine graph. So if you will remember your 4 steps, where you start, and then your 4 steps till you end, you can always graph these. All right? So I want you to try one. 3a is cosine of 1/2 x. That's what x over 2 means. And then 3b, I want you to do sine of 3x. Sine of 3x. So give me your amplitude. What is your amplitude for that cosine of 1/2 x? What is your amplitude for sine of 3x? And then I want you to graph your cosine, graph your sine using the new amplitude. The new amplitude. So in your books, it gives you some key points of your sine and cosine. Domain. You can really input any angle from negative infinity to positive infinity. Think about your x value here, okay? On that axis that I had. Because it is a cycle, you could say pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 156 pi if you wanted to, right? For what your input is. So your input or your domain can be anything. Your range, however, is only going to be between -1 and 1. Well, why is that? Well, first of all, think about way back in right angle trigonometry. It is opposite over hypotenuse, right? That is SOHCAHTOA. That is our sine. Your sine can never be bigger than 1 because your hypotenuse will always be the biggest side. And if I look at my 90-degree, opposite and hypotenuse are actually the same thing, which is what yields the 1, right? So if I were to take my right angle in my right angle trigonometry, all right, this is the hypotenuse. What is opposite for my right angle? It is also hypotenuse, is it not? So the sine of a 90-degree angle should be 1 because it is the same thing over the same thing, right? Does that make sense? So that's why it's never going to go outside of 1 because the most you can have is the same side over the same side, which is 1, okay? Now, because we are now on a coordinate plane, we can also have -1, okay? Because my radius, my hypotenuse is always positive, but on a coordinate plane, I could have a negative opposite, so to speak, or a -y, okay? So my range is always going to be 1 to -1 there. My intercepts, well, and you're going to have multiple intercepts on the sine graph. You can see that it crosses the axis multiple times, okay? So x-intercepts, it's going to cross every time you hit a 0, right? That's where we're going to cross. Symmetry. All right, this is considered an odd function. This is symmetric to the origin. If you remember way back when we were talking about symmetry, okay? It can be symmetric to the y, to the x, or to the origin. This particular one is symmetric to the origin. Extremes, and I'm not going to have you, other than I want you to know the 1 and the -1. End behavior doesn't exist because this is a wave. So you don't have it shooting off to infinity one way or the other. It literally goes up and back down, up and back down. It's a type of oscillating function. All right, oscillating mean it goes just back and forth. If you think about what an oscillating fan does, right? It just goes back and forth. This is what a wave function does. All right, and then they've given you a picture of what it looks like. All right, you start at 0, you go up to 1, back down to 0, down to -1, and back up to 0. Okay, back up to 0. Cosine, you'll notice it has really kind of the same things, right? Continuous, your input and your range are the same. Your extremes are the same. End behavior is the same. It oscillates the same. All you do for the cosine graph is you take the sine graph and you just flip it by a pi over 2. You just shift it. That's all that's happened to him, all right? So let's look at things that can happen with your sine graph. The first thing we're going to talk about is the word amplitude, okay? The word amplitude. Amplitude is the first thing on your little handout there. Your function will be written like this. You can multiply the entire function by a number. On the inside of what you're taking the sine of, you can multiply your degrees or radians by a number, and you can add something to them. Or outside of the function, you can add something to it as well. Think about when we shifted our parabolas, right? Inside the function shifts it left and right. Outside the function shifts it up and down, all right? Multiplying it by a number stretches or squishes the function. That's the same thing that happens to a cosine sine, all right? So the first thing we're going to talk about is amplitude. Amplitude is always equal to A. So the number in front of your function is going to be your amplitude. So amplitude equals A. A. Amplitude determines how far the graph goes up and down from what's called the midline. In this case, we have not shifted up and down yet. So our midline right now is the x-axis. There are going to be times, however, when you can shift up and down. So it's always the midline. Your amplitude is how far away from where you started from you get, both positive and negative direction. All right? It's half the distance between your max value and your min value. But it is always represented by A. All right? So what does this mean when we graph? Well, when we graphing, then all of a sudden, what I'm graphing isn't going to go up as high or may go up higher. All right? If I have something like a fraction in front, my graph is going to shrink as far as how high it goes. If I have a number in front, my graph is going to stretch as far as how high it goes. So if we look at this guy, which is t tiny, all right, so we're just going to do this, and I'm going to only give you a little bit here of it. Oh, no, I don't want all of it. I just want him. All right. The only thing that changes is how high I go. So your graphs are basically divided into 4s. You have a starting point. You have an ending point, all right? Halfway from your starting to your ending, okay? Halfway in between those. So you have basically 4 sections, right? I have my first section, second, third, and fourth. So I'm going to start here, a fourth of the way through, half of the way through, 3/4 of the way through, and at the end, all right? For sine graph, I start at my midline, 0. 1/4 of the way through, I go to my highest point, which is my amplitude. So I'm going to look at the graph they gave me, which is right here, and my amplitude is 1/4. So my normal graph, sine of x, I would go all the way up here to 1. All right, I would go all the way up here to 1. However, the graph that they've given me, 1/4, I'm only going to go to 1/4. Everybody see that? Halfway through, for both of them, I'm going to be back at 0. Both of them, I'm back at 0, halfway through. 3/4 of the way through, I'm going to be at my lowest point. For a normal sine graph, my lowest point here is going to be -1. For the graph that they've given me with an amplitude of 1/4, I'm only going to go to -1/4. For my ending point on a sine graph, I am going to end where I started at my midline. So my normal graph looks like this. This is one cycle, which we'll talk about. That's my normal graph. The graph 1/4 sine x is going to look like this. Everybody see the difference? My amplitude just changed how far away I got from my midline. That's all it did. All right, let's look at this first one. Your cosine graph, you start at your highest point, which is normally +1. In this case, what's your amplitude? What is your amplitude for this one? 1/3. So that's as high as you're going to go, right? So for this one, we're going to say we start at my highest, which is 1/3. All right. 1/4 of the way through, which is pi/2. I'm going to be at 0. Halfway through at pi, -1/3. 3/4 of the way through, back at 0. And then all the way to the end, I'm back at 1/3. So it should look something like this. Okay? That's your cosine graph. Sine graph, what is your amplitude for this one? 5. For sine, I start at 0 or my midline. 1/4 of the way through, I'm at my highest point, which is now 5. Halfway back to 0. 3/4, my lowest, which is now -5. At the end, back at 0. So this guy is going to look like this. If we were wanting to graph just y equals cosine, where is that going to start? Yeah, it's going to start at my highest, down at 1/4 to 0, halfway to lowest, 3/4 to 0, end at highest, okay? So then let's look at y equals 1/3 cosine. We'll do this one first, all right? So instead then of going all the way to 1, we're only going to go to 1/3, right? So he's going to look like this. He's going to start at his highest, which is now 1/3, which is right here, right? Halfway through, or sorry, 1/4 of the way through 0, halfway through down to the lowest of 1/3, back to 0, highest is where we're going to end. And you can go back this way too, so it does the same thing, it just reverses, right? And so this would be my cosine of 1/3 right here. All right. Now, what negative does is it just flips it. All right. So if I were to do a negative coefficient here, and hopefully it talks about that right here. Looking at this particular graph here, if I want to say y equals -1/3 cosine of x, then instead of starting at my highest point, I am now going to start at my lowest point. My lowest point would be -1/3. I would still go to my 0 at 1/4, right? I would go to my highest, which is now +1/3 halfway through, back to 0, and then back down to my lowest. So it literally just flips that graph upside down. And so it now does this. It literally just reflects it across the x-axis. So if you have a negative amplitude, it just means, okay, the absolute value of the A is going to be how far away from the midline you get. But the negative tells you to go the opposite direction first. Your divisions are still the same. You still go start wherever you would start. Okay, for sine, it would start at 0. For cosine, positive amplitude starts at your highest value. Negative amplitude starts at your lowest value. All right, and then you follow the track from there. Look here, you can reflect. You'll remember we could reflect a quadratic, right? So quadratics normally point up parabola. A reflection would point down, right? And so if you had a negative in front of your quadratic, you knew automatically that that was going to be pointing down because it flips it upside down. That's what exactly happens to your sine and cosine functions, which you'll see this sinusoidal. Beautiful word for sine and cosine graphs, okay? All right, and so both of those will just flip, meaning that for sine, I would still start at 0, but instead of going up first and back down and then back up, I would go down first and back up. So it basically just takes that graph and just flips it upside down. Wherever you start, whatever your amplitude is, instead of going to the highest point normally, you would just flip it and go to the lowest point, all right? And so if we look at this, you'll see that the sine graph flipped because it had this negative in front of the sine, all right? And so if you look at this one, cosine versus -3 cosine. For a normal cosine, if I were just graphing cosine, I'm going to start up first, right? And they gave me a little tiny graph. Cosine graph, I'd start at 1. My halfway point would be 0, or 1/4 would be 0, halfway back down, 3/4 back at 0, end on my highest. And so it's going to look something like this. That's my regular sine graph right there, okay? Now they want me to graph -3 cosine. Well, cosine again, I normally start here, and I didn't give myself enough room, of course, so there's 3. I'm going to start at my lowest, right? I'm still going to go up to 0. I'm going to go highest here, back to 0, lowest here. And so this guy is going to look much sharper here, stretched out, and he's flipped. He's flipped over. All right. So that's all it does. That's all it does. All right. Period. The period of a sinusoidal function is the distance between any two sets of repeating points on the graph of the function. How long does it take to complete one cycle? Okay? How long does it take to complete one cycle? That is the period. The standard period for a sine cosine function is 2 pi. It takes 2 pi to complete an entire cycle. That makes a whole bunch of sense, considering the fact that a circle is 2 pi, okay? And that it goes through every single one of its options in 2 pi, okay? So the standard is 2 pi. However, you have a handout. There are going to be ones that do it in different timing than 2 pi based on something that is happening to the function. So on your handout, for period, you have a formula. That formula is 2 pi over the absolute value of b. Well, what is b? B is the number in front of the x inside your function. So amplitude is a. That is the number outside of your function in front of it. B is the number in front of your x or your theta inside the function. All right? So your period is going to be 2 pi divided by absolute value of b. Now what this means is if your b is a whole number, your period will get smaller. If it is a fraction less than 1, your period will get bigger because it's keep, change, flip, okay? So we're about to do some with fractions, and we're about to see how it stretches it out. We're still going to divide it into first quarter, second quarter, third quarter, end, all right, so that we can see how it does. But you have to figure out what your period is first, period and amplitude first, all right? So let's look at the example. Describe how the graphs are related, then find the period and sketch at least one period of both functions on the same coordinate axis. All right, so this first gives me cosine. Well, let's look at just cosine. We're going to do just cosine. All right, just my cosine of x. I start at 1. I go to 0 at my, now, okay, keep in mind, pay attention to where I am. This is 2 pi. So my 1/4, that's right here. So I'm going to go to 0, 1/4 of the way through. Halfway through is right here. Back up to 0, back up to my highest point. And it's going to do that really all the way. All right, so that's what my graph looks like right now. All right. And so I have this cosine graph here, my standard cosine graph, all right? And I did several waves, as you can see. What you'll notice is that from 0 to 2 pi, I did a complete wave, and then it started over, okay? My standard function. 0 to 2 pi, my wave started over, all right? Now let's look what happens when I have the next one. So let's look at this together. G of x is what they want us to graph now. Do it in red. G of x equals cosine x over 3 is 1/3 x, right? Everybody agree with that? X over 3 is 1/3 x, all right? So my amplitude is 1. I'm still going to go up to 1 and down to -1, right? But now I have to calculate period. So my amplitude here for this guy is still 1, but my period is going to be 2 pi over 1/3, right? Keep, change, flip. That's 2 pi times flip 3 over 1. That is 6 pi, which means I am going to complete one cycle in 6 pi instead of 2 pi. All right. So what I need to do is I need to take 6 pi. I need to divide it in fourths. Okay. The easiest way to do this is take 6 pi, find the halfway mark, find the halfway mark in between there, okay? So I'm going to take this graph off for just a second so that we can just do the new one, all right? And then let's divide. So we have my starting point and my ending point. That is easy. What is halfway between 0 and 6 pi? 3 pi. So this is my halfway mark, okay? What's halfway in between 0 and 3? 1.5. So if this is 1 pi, my 1.5 pi should be like right here, right? My 4.5 pi should be like right here, all right? Now, when you get crazy big or crazy small, just estimate it, okay? Eyeball where your halfway mark and where your first quarter and second quarter, okay? I'm not going to get a measuring tool out and be like, you're at like 1.7 pi. You know, I'm not going to do that, okay? So eyeball full, half, quarter, okay? Then I'm going to do exactly what I would do for any cosine function. I start at my highest point because my amplitude is 1. So I'm going to start at my amplitude. Start at 1, all right? Starting at 1. My fourth of the way through, I'm going to be at 0. So that's that marker. Halfway through, I'm going to be at my lowest, which is -1 because of my amplitude. 3/4 of the way through, I'm going to be back at 0. And at the end, I'm going to be back at my highest, right? That's what a cosine function does. If I went the other direction, it would just mirror, right? So I would just mirror it down. That is my cosine function. So find your starting and ending point. Do your halfway, your first and third quarter. And for cosine, you need to know all of these. So cosine, you start at your amplitude. 1/4 of the way through, you are at 0 or your midline. Halfway through, you're at your lowest. 3/4 of the way through, you're at 0 or your midline if that moved. We'll talk about that in a minute. And you end at your amplitude, okay? So that's what you need to know when you're graphing these. So when you do this, you start at your 0, you're going to end at 4 pi, halfway is at 2 pi, first quarter at 1, third quarter at 3 pi. For cosine, you start at 1 to 0, -1, back to 0. Back up to your highest. All right, for B, they want us to graph sine of 3x. All right, so my amplitude again, the number in front of sine, that is still 1. That's how far away I'm going. My period, though, is going to be 2 pi over 3. That's as far as I'm going to go. So where's 2 pi over 3? That's kind of important, right? You don't have a 1/3 on this graph. So if you think about it, here's pi. Here's halfway to pi. Here's a quarter of the way to pi. You are going to have to find 2 pi over 3. So you can get a common denominator if you want to kind of figure it out. Common denominators, let's do 12. So this is 6 pi over 12, right? That's 1/2, right? This is 9 pi over 12, right? 2 pi over 3 is going to be 8 pi over 12. Everybody agree with that? Right? So it's going to be about in between these two, but closer to this guy. So, you know, I mean, that's 1/3. It's probably going to be about right here. And I'm just eyeballing it, all right? So when you have to figure out where something is, just get as close to it as possible and then mark it. So this is 2 pi over 3, okay? 2 pi over 3. And once you figure out where it is, then you just have to do your halfway mark and your quarter marks. Now, if I'm looking at this and I want to do a halfway mark, I'm going to say 1, 2, 3, 4, 5.5, right? And so I'm going to put it maybe my halfway mark like here. Does that make sense? My quarter mark here, my quarter mark here. That's what I mean by eyeball it. Halfway, quarter, quarter. That's really what you need to know when you're graphing these, okay? Same thing over here. If it was just in front of 3 pi over 4, 3 pi over 4, half, oh, that's a quarter. Let's see, halfway, right, quarter, somewhere in there. You know, close enough. You just want to find your starting and ending point, cut it in half, cut those in half. All right? This is a sine graph, all right? So I have a sine graph. My amplitude is 1. Where do I start for a sine graph? So I start at 0, right? Or my midline. My first quarter, where's my first quarter? It's at my highest, right? So that's at my amplitude. Halfway through, I'm back at 0 or my midline. 3/4 of the way through, I am at my lowest or opposite of my amplitude. And I end back at 0 or my midline. All right, so that's what we're going to do. We start at 0 because I'm not changing anything here. My amplitude is 1, so at my 1/4, I'm at 1. At my halfway, I'm at 0. At my 3/4, -1, I finish back at 0. And so that's what I'm going to do here. All right, and so this graph's going to look like this. Much shorter than if I went all the way to 2 pi with it. All right? I just want to talk about what frequency is. When I make you list stuff, I don't make you list frequency, but I want you to understand the concept for when we do a word problem. And you should probably have heard the term frequency, but the frequency is the number of cycles a function completes in 1 unit interval. So for this, it's actually the reciprocal of the period. So if the period is 2 pi, your frequency is 1 over 2 pi, which means you complete one cycle in 2 pi. How many times do you complete a cycle in your 2 pi is basically what it's saying, okay? So that's why it's absolute value of b over 2 pi. So if it's 1/3, it's 1/3 over 2 pi. Frequency cannot be negative, neither can period. That's why you have that absolute value, right? Frequency is how many times it repeats a cycle in a certain unit. So that's what it means by frequency when you have a radio wave, all right? That's why they receive certain frequencies because they're looking for a specific wave pattern to receive that frequency, and that's why it then magically appears in your car, okay? It's a frequency, all right? And so it's how many times it cycles in one unit of measure, in this case 2 pi, all right? I will say that phase shift tends to be the most difficult one to deal with. It is simply a left-right shift, okay? So what I tell people to do is I tell people to start at 0, figure out where you're shifting left or right. That's your new starting point. And then just add your period to that, okay? Because you're going to start at a new point. We've been starting at 0. And if my period is 2 pi, then I end at 2 pi. All right? If my period's 3 pi, I end at 3 pi. Now phase shift is going to move that around. So if I shift a pi over 2, that's where I'm going to start. And I'm going to go from there to the end of my period. So if my period's 2 pi, I'm going to go to 2.5 pi, right? I'm going to go 2 pi plus another phase shift of that 2 pi. Now what you can do is figure out your period, figure out start and end, and phase shift both of those. So if it's start at 0, end at 6 pi like we did on that other one, and your phase shift is 1/2 a pi, you can shift your start over 1/2 and your end over 1/2 as well. And then do your halfway, your quarter, all right? But phase shift just means your left and right shift, all right? Now, I want you to pay attention to this. If you'll recall when we shifted functions inside the parentheses, that was my left and right, and it was opposite of the way you would think. So if you look at this formula for phase shift, you will notice this negative c over the absolute value of b, because it is going to shift opposite of what it looks like on the inside. All right, so if it's a minus on the inside, like a minus c, you're going to actually do a positive shift. If it's a plus c, you're going to do a negative shift, okay? And so it's just like any other shift inside the function. It's opposite when you do left-right, okay? So it is c, negative c, over absolute value of b. Let's look at an example. All right, so look at this one right here. My amplitude, and I'm going to walk through these every single time. My amplitude for this is a. What's the number in front of sine? 1. All right. My period is going to be 2 pi over the absolute value of b. What is b? 3. So it's 2 pi over 3. All right. My phase shift is going to be negative c. What is c? C is negative pi over 2. So negative pi over 2 is pi over 2 over b. What is b? 3. Now remember, keep, change, flip. So that's pi over 2. Change it to multiplication. The flip of 3 is 1/3. So my phase shift is pi over 6. Okay, pi over 6. Everybody see what's going on here? All right, I'm going to cut this guy a little bit because he's a little too big for me for a period of 2 pi over 3. All right. All right, so just take your time. Just give me a second here. We'll get it done. All right. Now, so normally for a sine graph, I would start at 0, right? And I would go to my end based on my period. What's my period? 2 pi over 3, all right? 2 pi over 3. Now, 2 pi over 3, we already established was somewhere between 1/2 and 3/4, right? So it's about right here. So this is where I would normally start and end this guy. Does that make sense? But now I have to shift pi over 6. Pi over 6 is going to move me right 1/6, a little teeny amount, right? And so 1/6, I mean, that's like a sixth of all the way to here, right? So this is half of all the way to here. I mean, he's like tiny. So we're just going to shift him 1/6 this way. Let's just say that's 1/6. So that means we have to shift our end, which was here, right? Our end was right here where my lightsaber is, right? So we're going to shift him over as well, 1/6. All right? Does everybody see that? So now I have a new starting and ending point. New starting and ending point. I'm going to take this new starting and ending point and I'm going to divide it in half. I don't care if you eyeball it, then into fourths. All right? So everybody see my new half, 1/4, and 3/4 marks. All right? So that's what I'm going to use my graph on. My amplitude is going to be the same. I've already established my period now and my phase shift. So now I just graph, all right? So for a sine graph, I start at my midline, which right now is still my 0. My quarter mark, which is now right here, I go where? To my amplitude. My amplitude is 1, right? Halfway mark, I go back to 0. 3/4, I go down to -1. I end at my 0. And you can just pull it out a little bit further. But you can see that's what it's going to look like. And so if I were to, go back through this guy, then you can see that it's going to follow basically the same pattern here. Basically the same pattern. It's going to just shift this way, right? And so we're going to do the same thing if we kept going. All right, so same graph, you're just literally shifting it left or right. So I find it easiest to establish my beginning and end, and then move it, and then do halfway, 1/4, 3/4. All right? I want to really quickly look at vertical shift, because we're going to do a handout with this tomorrow and only do graphing of these things tomorrow, okay? So let's look at vertical shift really quickly, and then we'll be done. Vertical shift means it moves it up and down. Your vertical shift is based on your D. Your D, all right? So, D moves it up or down. Exactly the way you would think it would. A positive D moves it up, a negative D moves it down. Just like any other graph. The guy on the outside moves him up or down, plus or minus, all right? What this does is it changes my midline. So my midline has been my x-axis. So if I had an amplitude of 3, I would say I go up to +3 down to -3, right? If my midline changes, my amplitude takes me that many units away from my midline. So I draw my midline on my graphs, is what I do. Let's look at this example. They've given me all of the above, all right? So they've given me this function right here. Let's establish everything that we have. We have an amplitude. They are nice, and they just said 1. Why did they not give me a bigger amplitude? Let's do an amplitude of 3, because I actually want you to see it. All right, so make it a 3 sign. Amplitude of 3. All right. Period. They were nice with period. 2 pi over b, which is 1. So my period is just my 2 pi. That's nice. Okay. Phase shift. Phase shift. That's negative c, which is 2 pi, over b, which is 1, right? So just negative 2 pi. That's a weird phase shift, but whatever. That's actually not going to make it look like it changed at all. All right. And then my midline. So my vertical shift is going to be at y equals -1. That's where my new line is going to be, -1. Everybody see that? My vertical shift is -1. So here's what I do. I take that -1 and I actually draw, my graph is like crooked. I actually draw a dotted line here, okay? So I take this guy and I draw a dotted line at -1. And I say, okay, this is my new starting point, okay? Which means, now my phase shift actually is 2 pi, so it actually shifts an entire cycle. If it's 2 pi, you don't have to move it at all, bless you. If it's any multiple of 2 pi, you don't have to move it, all right? But now my starting point for a sine graph is going to be at my midline. That's my starting point, okay? I'm still going to have ending here, halfway here, 1/4, 1/4. My amplitude is 3. So I'm going to go 3 up from my midline, which is just positive 2. I'm going to go back to my midline for my halfway point, which is pi, which is at -1. Then for my 3/4, I'm going to go 3 away from -1 this way. That's -4. And then I go back to my midline. So your midline change, that's why I draw it. Your amplitude takes you that many away from your midline. All right? Does everybody understand that? Midline's easy. You literally just have to do a dashed line where you're starting and pretend that's your x-axis. All right? Then count up, count down.